over the past few days, something insane has started happening in our solar system. A mysterious interstellar object called 3I Atlas, a visitor from deep space, just got way, way brighter. And right at that same time, the sun went absolutely wild. Massive solar eruptions, extreme coronal mass ejections, and radiation storms are firing off in every direction, and some of them might soon be heading straight toward us. Coincidence? Maybe. But the timing is just too perfect. If you love real cosmic mysteries, not sci-fi but the real thing, make sure you're subscribed, because what's happening right now with 3I Atlas and the Sun might become one of the biggest space stories of the decade. The story of this strange visitor begins not with a bang, but with a flicker. It started with a subtle flicker of light in the deep black of space, and then suddenly 3I Atlas exploded in brightness. To understand why this was so strange, we first need to understand what this object is. 3I Atlas is an interstellar object. That name sounds complicated, but it means something very simple. It means this object is not from around here. It is not native to our solar system. It did not form with our planets, with Earth, or Jupiter, or Mars. It was born somewhere else, in a different star system, millions of miles and millions of years away. It is a true alien visitor, a traveller from a distant, unknown place. This wasn't the first time we'd seen such a visitor. Our solar system has had guests before. We briefly recall other interstellar visitors that captured our imagination. In 2017, an object named Oumuamua tumbled through our system. It was long and thin, shaped like a cigar, and it moved in a way that puzzled scientists. It didn't have a tail like a comet, but it was speeding up as if something was pushing it. It left us with more questions than answers. Then, in 2019, another visitor arrived. Its name was Borisov. This one was easier to understand. Borisov looked and acted like a comet. It had a visible tail of gas and dust, and we could study it more closely. It was a piece of another solar system, but it was a piece we could recognize. These visitors were important. They were like messages in a bottle, thrown into the cosmic ocean from a distant shore. They told us that the building blocks of other star systems might be similar to our own. But 3I Atlas was different. Something about it stood out and made scientists pay very close attention. What made 3I Atlas special was its unexpected light curve surge just before October 29th. A light curve is just a graph that shows how an object's brightness changes over time. For most comets and asteroids, this change is predictable. As they get closer to the Sun, they warm up and release gas and dust, which makes them look brighter. We have models that can guess how bright they should get. But 3I Atlas didn't follow the rules. Its brightness spiked. It shot up far beyond what any of the prediction models said was possible. It was as if someone had suddenly flipped a giant switch, turning its light from a dim bulb to a powerful searchlight. This strange brightening happened as the object was making its closest approach to our star. This moment has a special name. It is called Perihelion. Perihelion is the point in an object's journey where it is nearest to the Sun. For 3I Atlas, this close approach was just 1.36 astronomical units. An astronomical unit, or AU, is the distance from the Earth to the Sun. So 1.36 AU means it was a little farther from the Sun than we are, but still very much in the warm, inner part of our solar system. At this distance, the Sun's energy is incredibly powerful. Every patch of space is flooded with light and heat. We can measure this energy. It was around 735 watts per square meter of radiation. To put that in perspective, that is billions of times more energy than the object felt when it was drifting in the cold, empty darkness of deep interstellar space. It was like stepping out of a deep freezer and walking directly into a furnace. Visually, it was a stunning sight for our telescopes. We saw a blazing, comet-like body moving near the solar disk. Powerful cameras and data overlays showed us just how much energy it was reflecting. The data poured in from observatories all over the world. Every time an object gets this close to the Sun, we expect some brightening. We expect it to wake up from its long journey. But this was something else. This was an awakening so intense it broke all our expectations. Its brightness spiked far beyond any prediction models. Scientists around the globe started asking urgent questions. What could possibly cause this? Was the object fragmenting? Was it breaking apart under the Sun's intense pull? Or was it reacting to something we couldn't see? Was there some unknown material on its surface? Something from its home star system? that was reacting to our sun's energy in a completely new and unexpected way. The mystery of 3i Atlas was just beginning. It was not just a visitor anymore, it was an anomaly, an event that challenged what we thought we knew. And right when the world's telescopes locked onto 3i Atlas, the sun decided to respond. The timing was more than just a coincidence. It was a signal. A moment in space where two powerful forces seemed to be talking to each other. For astronomers, it was a moment of pure focus. All around the globe, giant metal eyes turned toward this one small point of light. These telescopes are some of humanity's greatest achievements. They are built on high mountains in dry deserts, and even sent into space, all to escape the blurry air of our own world. They are designed to see the faintest, most distant objects. Their job is to collect light that has travelled for thousands, even millions of years, just to reach us. And at this moment, many of them were pointed at 3i Atlas. They were trying to understand its sudden, shocking brightness. Scientists in control rooms watched their screens, their faces lit by the glow of incoming data. They were gathering every piece of information they could. They were measuring its light, its colour, its path. They were trying to solve the puzzle. In the silence of space, two dramas were unfolding. One was the story of the interstellar visitor 3i Atlas, a lonely traveller that had suddenly become a brilliant spectacle. It had spent ages in the cold and the dark, and now it was putting on a show for us. A show we did not understand. The other drama was happening at the very centre of our solar system. Our own star, the sun, was stirring. It was like a sleeping giant beginning to wake. The sun is a constant presence in our lives. It gives us light, warmth, and energy. We often think of it as a steady, peaceful ball of fire in the sky. But the sun is not peaceful. It is a place of constant, violent activity. It is a fusion reactor, a giant ball of churning plasma, a magnetic engine of unimaginable power. And something was about to trigger that engine. Something was about to wake the giant in a very big way. The focus of the scientific world was on the visitor. They were trying to answer the question, why did 3i Atlas get so bright, so fast? Was it made of something new? Did it have a strange kind of ice on its surface that exploded when heated? Was it hollow? Was it spinning in a weird way? Every new piece of data only deepened the mystery. The brightness was not supposed to be this high. The light it was giving off was not the right colour for a normal comet. Everything about it was just a little bit off. It was like hearing a familiar song played in a key you've never heard before. It was recognisable, but also deeply strange. And while the best minds on our planet were looking at this small distant object, they were about to be distracted. They were about to be reminded that the most powerful object in our neighbourhood is not some mysterious visitor. It is the star we see every single day, the star we take for granted. The connection was not obvious at first. How could a tiny object, millions of miles away, affect the sun? The sun is 1,000,000 times bigger than the Earth. It contains more than 99% of all the material in the entire solar system. It is a force of nature on a scale that is hard to even imagine. 3i Atlas, by comparison, was just a speck of dust, a tiny pebble next to a raging bonfire. So the idea that one could influence the other seemed impossible. It seemed like something out of science fiction. But the universe is a strange place. It is full of forces we're only just beginning to understand. Forces like magnetism and plasma, which can connect things over vast distances. The space between the sun and 3i Atlas was not empty. It was filled with the solar wind, with magnetic fields, with invisible rivers of energy. Perhaps the visitor did not need to be big to have an effect. Perhaps it just needed to be in the right place at the right time, carrying the right kind of electrical charge. As our telescope stared at the brightened traveller, the star it was visiting began to stir. And the timing was just too perfect to be ignored. The sun decided to respond. Almost simultaneously, the far side of the sun began to erupt. This was not a small event. This was the sun showing its true power. Our star has two sides, just like a spinning ball. The side that faces Earth and the side that faces away from us, known as the far side. We have special satellites that watch the whole sun, so we can see what's happening on the far side long before it rotates into our view. And what they saw was breathtaking. It was a display of raw cosmic violence. Coronagraph visuals showed it clearly. A coronagraph is a special kind of telescope that blocks out the main light of the sun, so we can see the much fainter atmosphere around it, called the corona. It is like putting your thumb up to block the sun, so you can see the sky around it. And what these coronagraphs showed was boom after boom after boom. A series of explosions, each one bigger than the last, all happening on the part of the sun turned away from us. Scientists looked at the data pouring in from these solar observatories, and they saw a storm of historic size brewing. They saw gigantic coronal mass ejections, or CMEs. A CME is one of the most powerful explosions in our solar system. The sun's magnetic fields get twisted up like rubber bands, and when they finally snap, they launch a huge cloud of solar material out into space. This cloud is made of plasma, a superheated gas, and it can contain billions of tons of material. It travels at millions of miles per hour. These were not just any CMEs, these were huge. Along with them came multiple X-class flares. Solar flares are giant bursts of radiation. We classify them like hurricanes, with letters like CM and X. X-class flares are the most powerful. They are major events, capable of causing radio blackouts on Earth, even from millions of miles away. And the sun was firing them off one after another. The space around the sun was filled with these explosions. We could see the shock waves expanding out through space, like ripples in a pond after you throw a giant rock in. These shock waves were pushing the solar wind, speeding up particles, and flooding the inner solar system with a storm of energy. Luckily for us, it was not Earth-facing. Not yet. The part of the sun that was exploding was pointed away from our planet. If it had been pointed at us, we would have known about it instantly. Our satellites would be in trouble. Our power grids would be under stress. But for now, we were just spectators, watching the fireworks from a safe distance. But the scale of these eruptions was insane. This was not normal solar activity. This was something bigger, more violent. The sun was going through a period of extreme rage. The timing made it feel like more than just a coincidence. It felt like the sun had been waiting for this moment. It felt like the arrival of 3I Atlas had somehow tripped a wire. The visitor from another star system journeyed for millions of years. It finally enters our inner solar system, getting close to our star. It suddenly brightens in a way we cannot explain. And at that exact moment, the sun begins to roar with a fury we have not seen in a very long time. The CMEs spiked. The flares erupted. The connection was hard to prove, but it was also impossible to ignore. Two very different cosmic events were happening at the same time. One was the mysterious brightening of a visitor, the other was the violent awakening of our own star. And the story was far from over, because the sun keeps turning, and that angry part of the sun was slowly, day by day, rotating to face us. The storm was coming our way, and as the sun went into overdrive, 3I Atlas hit its closest point to the star, and the connection between the two became impossible to ignore. The sun was not just having a single bad day. It was entering a state of high alert, a period of sustained violent activity. We can think of it as going into overdrive. Like a car engine that is suddenly pushed to its maximum speed, the sun's internal engine was revving up. Its magnetic fields were twisting and snapping with more frequency and more power than usual. The number of sunspots, which are the dark, cooler areas on the sun's surface where these magnetic storms are born, was increasing rapidly. These were not small sunspots. These were huge complexes, some of them many times larger than the entire planet Earth. They were the visible signs of the turmoil happening deep inside the star. This overdrive state meant that the explosions were not just a one-time thing, it was a cascade. One eruption seemed to trigger another, creating a chain reaction of solar fury on the far side of the sun. At the very same time this was happening, 3I Atlas was reaching the most important moment of its journey through our solar system. It hit its closest point to the star. This is perihelion, the moment of maximum heat and maximum gravitational pull. It is the point where the sun's influence is strongest. For any object from the cold, outer reaches of space, this is a moment of extreme stress. The heat can vaporize ices that have been frozen for billions of years. The sun's gravity can pull the object apart, and the radiation can change its surface in fundamental ways. It's a trial by fire. For 3i Atlas, this moment was not just a point on a map of the solar system. It was an interaction, a moment where its own nature was being tested by the star. And as it reached this critical point, the sun's rage seemed to peak. The timing was too perfect. The connection between the two events became impossible for scientists to ignore. In science, you're trained to be skeptical. You're taught not to jump to conclusions. You look for proof. You look for data. Coincidence is the most common explanation for two things happening at the same time. But as the data kept coming in, the idea of coincidence started to seem less and less likely. You had two timelines. The timeline of 3i Atlas, showing its steady approach, its sudden brightening, and its arrival at Perihelion. And you had the timeline of the Sun, showing a period of normal activity, then a sudden switch to extreme, violent eruptions. And these two timelines matched up almost perfectly. The brightening of the visitor happened right as the Sun's far side began to explode. The visitor's closest approach happened right as the Sun's activity reached a frantic peak. Scientists began to seriously consider that this was not a coincidence at all. They started looking for a link, a physical mechanism that could connect a small interstellar object to a giant star. How could one trigger the other? The space between them, while it looks empty, is filled with invisible magnetic field lines. It's a complex web of energy that connects everything in the solar system. Perhaps 3i Atlas, as it passed through this web, created a disturbance. Think of a spider's web. A tiny fly landing on one strand can cause the entire web to vibrate. Maybe 3i Atlas, with its own unique magnetic or electrical properties, was the fly in the Sun's magnetic web. Its passage could have created a ripple, a disturbance that travelled along the magnetic field lines to the Sun's surface, triggering the storms that were already waiting to happen. The Sun was already loaded like a gun. Perhaps 3i Atlas just pulled the trigger. The connection was no longer a wild idea. It was a serious scientific question. And it was a question that had urgent importance, because that angry part of the Sun was still turning toward us. October 29th, 2025. This was the day the visitor met the star. This was the day of Perihelion. This was the moment that all the astronomers had been waiting for. It was the point of closest approach, the moment where the interaction between this alien object and our Sun would be at its most intense. For weeks, 3i Atlas had been falling toward the Sun, picking up speed, getting hotter and brighter, and on this day it reached the bottom of its fall. It swung around the Sun in a tight, fast curve before it would be flung back out into the darkness of space, never to return. This was not just a point on a calendar, it was a critical event, a moment in time that could reveal the true nature of this mysterious object. And it could also reveal the nature of its strange connection to our star's violent outbursts. Everything was leading up to this single day. NASA's solar probes were in the perfect position to watch the show. We have a fleet of robotic spacecraft that are constantly watching the Sun. Satellites like the Solar Dynamics Observatory, or SDO, and the Parker Solar Probe, which flies daringly close to the Sun itself. These probes are our eyes on the star. They can see it in different kinds of light, measure its magnetic fields, and track the giant eruptions as they blast off into space. And on October 29th, they captured the alignment. They saw the path of 3i Atlas as it passed near the Sun, and they saw what the Sun was doing at that exact moment. The data they collected was priceless. It was a snapshot of this unique cosmic event, recorded for scientists to study for years to come. They were watching a historic meeting, and their cameras were rolling. The probe saw more than just the object's path. They saw it fly through a storm. They saw the detail of the coronal mass ejection waves striking near its path. These were not gentle waves. These were tsunamis of superheated plasma, shock waves of energy and radiation, all coming from the angry sunspots on the Sun's surface. 3i Atlas was flying directly through the battlefield. The region of space it was passing through was being flooded with solar plasma. The radiation surged to incredible levels. It was like a small ship trying to sail through a hurricane. This was the most hostile environment the object had faced on its entire journey. The data from our coronagraphs, called CCR1 and C3, confirmed its location. We could see the faint smudge of the object moving through the ghostly white tendrils of the Sun's corona, even as massive clouds of plasma erupted nearby. Amidst all this chaos, one thing remained stable. NASA's Jet Propulsion Laboratory, or JPL, tracked its movement with incredible precision, and their positional data showed that its trajectory remained normal. Its path through space did not change. It was following the predictable curve of gravity just as expected. It was not knocked off course by the solar blasts. It was holding steady on its journey. But this is where the story takes a twist. A normal trajectory does not mean normal behaviour. An object can stay on its path while still undergoing dramatic changes. Its orbit was stable, but the object itself was not. Because right after that encounter, right after it flew through the solar storm at its closest approach to the Sun, 3I Atlas flared up like nothing we had seen before. The moment of impact was not about changing its direction. It was about changing its very nature. The visitor had met the star, and it had been transformed by the experience. The real fireworks were just beginning. It brightened so dramatically, astronomers had to rewrite their projections in real time. The change was not small. It was not a minor adjustment. It was a huge sudden leap in brightness that took everyone by surprise. Before this event, scientists had models. These models are based on thousands of other comets and asteroids we have observed over the years. They take into account the object's distance from the Sun, its size, and what we think it is made of. The models for 3I Atlas predicted that at its brightest, it would reach what we call a magnitude of 9. In astronomy, the lower the magnitude number, the brighter the object. A magnitude of 9 is quite dim. You would need a good amateur telescope to see it, but what actually happened shattered those predictions. The actual magnitude didn't just reach 9, it soared past it. It hit a magnitude of 7.5. That might not sound like a big difference, just a number and a half. But the magnitude scale is tricky. It's not linear. A change of 1 magnitude is about 2.5 times brighter. So a change from 9 to 7.5 is not a small difference. That is the difference between a dull, faint glow and a miniature explosion. It means the object was suddenly reflecting several times more sunlight than it had any right to. It was like expecting a candle and getting a searchlight instead. The data pouring into observatories was so unexpected that astronomers had to check their equipment. They had to make sure their telescopes were working correctly. Once they confirmed the data was real, they had to throw out their old models and start from scratch. They were watching something happen that they had never seen before, and they had to rewrite their understanding of what was possible in real time. This sudden flare-up was so bright that even more basic telescopes could now see it. To detect it, astronomers were using a technique called stacking. This is where you take many pictures of the same spot in the sky, one after another, and then use a computer to add them all together. This process cancels out the random noise and makes very faint objects appear much clearer. But after the flare-up, 3I Atlas was bright enough that it stood out even in single images, and when scientists looked closely at these new, brighter images, they noticed something else that was strange. Its composition was not behaving like a normal comet. One of the most recognizable features of a comet is its tail. As a comet gets close to the Sun, the ice on its surface turns into gas, creating a glowing cloud around it called a coma and a long tail that points away from the Sun. But 3I Atlas lacked the typical long tail. It had a fuzzy glow around it, but not the magnificent streaming tail we associate with comets. It was all head and no tail. This led to a storm of new questions. What could cause such a huge increase in brightness without creating a large tail? Scientists began to brainstorm possible causes, each one more exotic than the last. One idea was that it was a result of plasma reactions from the solar flares. Maybe the storm of particles from the Sun was interacting with the material on the object's surface in a new way, causing it to glow without releasing a lot of gas and dust. Another idea involved electrical currents. Perhaps 3I Atlas was a highly conductive object, and as it passed through the Sun's magnetic field, it created powerful electrical currents around its nucleus, its solid center. These currents could have heated the surface and caused it to glow intensely. And then there was the most exciting possibility of all. Perhaps the answer lay in its interstellar dust chemistry, a chemistry that is unknown in our solar system. Maybe it was made of materials that were formed around another star, and these materials react to our Sun in a way that our local rocks and ices simply do not. The light curve that broke the models also broke open a universe of new and exciting possibilities. But this was not just a comet mystery anymore, because the Sun itself was still building towards something far bigger. While astronomers puzzled over the strange behaviour of 3i Atlas, the other half of this cosmic story was continuing to unfold. The focus had been on the visitor, on its strange light and its mysterious composition. But the star it was visiting was not finished with its performance. In fact, it was just warming up. The massive eruptions on the far side of the Sun were not the grand finale. They were just the opening act. The Sun was not calming down, it was gathering its strength. The energy inside it was building, twisting its magnetic fields into even more complex and unstable shapes. Scientists who study the Sun knew that the real show was yet to come. The initial blasts were a warning, a sign that our star was entering a period of high instability. And that instability was building towards something that could have a direct impact on us here on Earth. The mystery of 3i Atlas was fascinating. It was a puzzle from another star system, a chance to study something completely new and alien. But it was a distant puzzle. It was happening millions of miles away. It posed no direct threat to us. It was a story for scientists and stargazers. But the Sun is a different kind of story. The Sun is not a distant academic puzzle. It is the engine of our world. Its behaviour affects us directly, in profound and sometimes dangerous ways. Its light and heat give us life, but its storms can threaten our technology and our way of life. The solar activity was not just a curiosity, it was a potential threat. And that threat was growing. The energy being stored in the Sun's atmosphere was reaching a critical point. All it needed was a trigger to be released. So as one mystery deepened, another grew more urgent. On one hand, you had the question, what is 3i Atlas and why is it behaving so strangely? On the other hand, you had the question, what is the Sun about to do next? And the most unsettling part was the feeling that these two questions were connected. The strange visitor and the angry star were part of the same story. The events were linked. One seemed to be influencing the other. This was not just a comet mystery anymore. It was a solar system mystery. It involved the visitor, the star, and potentially us. The focus of our attention had to shift. It had to move from the small, bright object flying away from the Sun back to the giant boiling star at the centre of everything. Because the Sun was still building. It was building toward a climax. And that climax was pointed directly at us. The real danger was not from the visitor. It was from our own star. And it was getting closer every single day. Just as 3i Atlas blazed brighter, the Sun began to fire off a chain of massive eruptions. The timing remained perfect, almost like a coordinated dance. One partner, the interstellar visitor, lit up in a final brilliant flash. The other partner, our Sun, responded with a new wave of fury. It was a cascade of storms, one after another, in a relentless series of explosions. This was not a single event, but a sustained campaign of solar violence. Real-time data from our solar observatories showed the whole thing happening. We could see the Sun's surface in extreme detail, and we saw consecutive CMEs blasting off over a period of 10 days. The timeline was clear. From October 21st to October 30th, the Sun was in a constant state of eruption. It was as if a whole series of volcanoes were erupting at once all over the surface of the star. Each of these coronal mass ejections was an event of unimaginable scale. Each one released billions of tons of plasma into space, billions of tons of the Sun's own material, launched outwards at incredible speeds. This plasma is a fourth state of matter, a gas so hot that its atoms are stripped of their electrons. It's a cloud of charged particles, a magnetic bomb. Accompanying these plasma clouds were waves of energetic particles. These are tiny subatomic bits, mostly protons, that are accelerated by the explosions to speeds very close to the speed of light. They are like tiny bullets, and they travel so fast that they can reach Earth in a matter of minutes after an eruption. They are one of the biggest dangers to astronauts and satellites in space, and the Sun was now flooding the solar system with them. This level of intense repeated activity was not something we see every day. Scientists who have been studying the Sun for their entire careers knew they were watching something special. They had to look back in the history books to find something similar. This level of activity has not been seen since the 2003 Halloween storms. That was a famous period of solar violence that happened in late October and early November of 2003. The Sun produced some of the most powerful solar flares ever recorded. It caused power outages in Sweden, damaged dozens of satellites, and forced airlines to reroute flights to avoid radiation risks. It was a wake-up call, a reminder of what the sun is capable of, and now the data was showing that the current storm was reaching that same level of intensity. It was just as powerful, just as relentless. There was one key difference though, one lucky break for us here on Earth. This time, the storm was on the sun's far side for now. Just like in the beginning of this story, the most violent explosions were happening on the side of the sun facing away from us. We were shielded from the worst of it by the bulk of the sun itself. We could see the explosions happening on the edges of the sun. We could see the giant loops of plasma rising up and the clouds of material blasting out into space, and our far-side monitoring satellites confirmed the scale of it. But the main blast was not aimed at us. We were safe for the moment, but everyone knew that this safety was temporary. The sun rotates, and the giant angry sunspots that were creating this storm were slowly, unstoppably, turning to face Earth. The countdown had begun, because the sun rotates, and those monster sunspots are now turning directly toward Earth. The sun is not a solid rock. It is a giant ball of gas, and it spins on an axis just like the Earth does. But because it is not solid, it spins at different speeds. At its equator, it completes one rotation in about 25 Earth days. At its poles, it takes longer, around 35 days. But for things on its main body, we can use an average rotation period of about 27 days. This rotation is one of the most important facts about our star. It means that any feature on the sun's surface, like a sunspot, will eventually turn to face us. You cannot hide on the sun. Sooner or later, every part of its surface will come into view, and that is exactly what was happening now. The massive active regions that had unleashed those far-side flares were about to come into Earth view. An active region is the name scientists give to an area on the sun with a particularly strong and complex magnetic field. These are the places where sunspots form and where solar flares and CMEs are born. The active regions on the far side were some of the biggest and most complex scientists had ever seen. They were churning with magnetic energy, a tangled mess of forces just waiting to snap, and for over a week they had been the source of the solar storm cascade. We knew they were powerful because we had seen what they could do when they were pointed away from us. The question now was, what would they do when they were pointed directly at us? Helioseismic data showed it clearly. This is a technique where scientists study sound waves moving through the sun to map its interior and its far side. It's like doing an ultrasound on the star, and this data confirmed that the monster sunspots were huge, they were still growing, and they were heading our way. Animations made from the satellite data showed the whole process. You could see a computer model of the sun slowly rotating. On the far side, you could see bright patches glowing with intense magnetic activity. These were the active regions, and day by day, you could see them creeping around the edge, moving from the far side to the near side. It was like watching a villain in a movie slowly turning to face the camera. The tension was building with every frame of the animation. Scientists at space weather prediction centers around the world were watching this rotation with a mixture of excitement and concern. They were about to get their best look yet at these powerful sunspots, but they also knew the danger that came with them. Within days, Earth would be directly in the firing line. Our planet would be staring right down the barrel of the sun's most powerful cannons. This is where the parallel to the 2003 Halloween storms becomes so important. We build suspense by looking at the past. Back in 2003, the storm was also caused by a set of unusually large and powerful active regions. They also rotated into view and then unleashed their fury directly at Earth. History was repeating itself. The same setup, the same kind of powerful sunspots, the same rotation into the line of fire. It was an eerie echo of one of the most powerful space weather events of the modern era. We had seen this movie before and we knew how it ended. The only question was whether this new storm would be even bigger than the one that came before. All we could do was watch and wait as the sun continued its slow, deliberate turn. And that parallel is not just a coincidence, because back in 2003, something eerily similar happened when Mercury lined up with Earth. To understand this, we have to look beyond just the sun. We have to look at the positions of the planets and how they might influence our star. The solar system is not just a collection of separate objects. It is an interconnected system. The planets pull on each other with gravity. They move through the sun's magnetic field, and sometimes these interactions can have surprising effects. In 2003, during the famous Halloween storms, there was a special alignment in our solar system. The planet Mercury, the closest planet to the Sun, was in a direct line with the Sun and the Earth. This is a common enough event, but this time it seemed to be important. Let's quickly recap just how powerful those 2003 storms were. They were driven by a sunspot region so large it was visible from Earth without a telescope, if you had the right eye protection. This region produced multiple X-class flares, including one that was so powerful it overloaded the sensors on our satellites. We think it was an X-28 flare, the most powerful flare ever measured. The storm that followed caused auroras, the northern and southern lights, to be seen as far south as Florida and Texas in the United States. It damaged several satellites permanently. It caused a power outage in Sweden that left 50,000 people without electricity. It showed us just how vulnerable our modern, technological world is to the sun's anger. It was a clear warning. Now, let's go back to that strange alignment. At the peak of the storm, you had the Sun, Mercury and Earth all lined up. Why would this matter? Both Earth and Mercury have magnetic fields. Earth's magnetic field, our magnetosphere, protects us from the worst of the solar wind. Mercury has a much weaker magnetic field, but it is still there. So in 2003, you had a situation where two planets with magnetic fields were in perfect alignment with the Sun. It created a kind of magnetic connection, a channel stretching from the Sun past Mercury all the way to Earth. It is a controversial idea, but some scientists believe that this alignment might have helped trigger the eruptions, or at least provided a clear path for the energy to travel toward us. The Sun erupted with incredible force right when this magnetic connection was strongest. Visually, you can imagine a diagram of the solar system. You see the Sun at the center, you see tiny Mercury close to the star, and you see Earth a little farther out, and then you see a glowing line connecting them, a line of magnetic force, an invisible river of energy flowing between these three bodies. This idea suggests that planets are not just passive balls of rock. They are active players in the solar system. Their magnetic fields can interact with the Sun's magnetic field in complex ways. It's a theory that is still being debated, but the alignment in 2003 was a powerful piece of evidence. It showed a strange correlation between the positions of the planets and the activity of the star. And it is this very idea that makes the current situation with 3i Atlas so fascinating and so potentially dangerous. Now replace Mercury with an interstellar plasma body, and you begin to see why 3i Atlas might not just be a bystander. This is where the story gets really interesting. We take the idea from 2003, and we apply it to what is happening right now. In 2003, the trigger, or the amplifier, was Mercury, a small, rocky planet with a weak magnetic field. Now, fast forward to today, we do not have Mercury in the same position. But we do have something else. We have 3i Atlas. And 3i Atlas is not a simple dead rock like Mercury. It is an active, plasma-rich body. It is an interstellar object that reacted to the Sun with a sudden massive release of energy and gas, creating a cloud of charged particles around it. It is, in effect, its own little magnetosphere. This brings us to a fascinating theory called electromagnetic coupling. It sounds complicated, but the idea is simple. It is the idea that two objects do not need to touch to affect each other. If they both have magnetic fields, or are electrically charged, they can be linked by invisible forces. They are coupled, connected by electromagnetism. And this is the theory for what might be happening between 3i Atlas and the Sun. The interstellar object, with its cloud of plasma and its own internal chemistry, could have a much stronger electrical or magnetic effect than a small planet like Mercury. It could be influencing the solar fields around it in a much more powerful way. It is not just passing through the Sun's magnetic web, it is actively changing it. It is plucking the strings of the web in a way that Mercury never could. To make this easier to understand, we can use a simple metaphor. Think of the Sun's magnetic field as the field around a giant magnet. It is there, but it is stable. Now think of 3i Atlas as a small, charged particle. A piece of metal with its own electrical charge. What happens when you throw a charged particle into a magnetic field? The system reacts instantly. The field lines bend and twist. Sparks can fly. The whole system is disturbed. 3i Atlas, as it flew through the Sun's corona, could have acted in the same way. Its unique alien composition might have made it a perfect conductor or a perfect disruptor. It might have created a short circuit in the Sun's magnetic field. This short circuit could have been the trigger for the massive explosions we saw. 3I Atlas may have acted like a temporary magnetic conductor, creating a pathway for energy to be released from the Sun's surface. It is very important to be clear here. This is a hypothesis. It is a scientific idea that tries to explain the facts we are seeing. It is not sensationalism. We are not talking about aliens or spaceships. We are talking about physics, about plasma, magnetic fields, and electricity. We are talking about a logical, though unproven idea that connects the two strange events we have been watching: the brightening of the visitor and the roaring of the star. The interstellar trigger hypothesis suggests that 3I Atlas was not just a bystander, a passive witness to the Sun's fury. It suggests that it was an active participant. It might have been the match that lit the fuse, and this idea adds a whole new layer of mystery and importance to our strange visitor from another star. It was not just a piece of rock, it was a catalyst. But whatever was happening out there in space was now starting to echo down here on Earth. The story is no longer just about distant objects. It is not just about the Sun or a visitor from another star. The effects of this cosmic drama are now reaching our planet. The energy that was unleashed by the Sun has travelled across 93 million miles of space, and it is beginning to interact with our world. We are no longer just watching the show, we are now part of it. The ripples from the solar storm are starting to arrive at our doorstep, and we are starting to feel them in ways that we can measure and observe. The events in deep space are having real, tangible consequences right here, right now. When a solar storm hits Earth, it does not hit the ground directly. It first collides with our planet's magnetic shield, the magnetosphere. This invisible bubble of magnetism surrounds our planet and protects us from the worst of the solar wind and cosmic radiation. But when a powerful storm hits this shield, the shield shakes, it vibrates, it can get compressed and deformed. This interaction creates what we call a geomagnetic storm. It is a major disturbance of our planet's magnetic field, and we have ways to measure how strong these storms are. We use something called the KP index. It is a scale that goes from 0 to 9, and it tells us how disturbed the Earth's magnetic field is at any given moment. The higher the number, the bigger the storm. We also use the G scale, which goes from G1 minor to G5 extreme, to classify the overall power of the storm. By October 30th, the data was clear. Earth entered a G1 level geomagnetic storm. This was the first gentle touch of the storm that had been brewing on the Sun's far side. It was not the main blast. This was the forerunner. The first wave of energy and particles that travelled faster than the main cloud of plasma. A G1 storm is considered minor. It is not a major threat to our technology, but it is a clear signal that something has happened. It is the first rumble of thunder that tells you a big storm is on its way, and we could see the effects of this G1 storm happening around the world. Visuals of beautiful auroras began to appear across the Arctic regions. The northern lights were more active and brighter than usual, a direct result of the solar particles hitting our upper atmosphere. Our scientific instruments on the ground, called magnetometers, which measure the magnetic field, showed the fluctuations clearly. Their needles were jumping, recording the magnetic disturbance in real time. And the effects were not just visible in the sky. Our technology started to feel it too. Satellites in orbit around the Earth reported fluctuations. The sensitive electronics on these billion-dollar machines were being hit by the increase in radiation. They had to be carefully monitored to make sure they were not damaged. Down on the ground, GPS accuracy dropped. The same signals that your phone uses to tell you where you are can be disturbed by changes in the atmosphere caused by a geomagnetic storm. For most of us, a drop in GPS accuracy is a small inconvenience. But for airplanes, for shipping, and for many industries that rely on precise positioning, it can be a serious problem. The narrator's tone here is one of controlled urgency. This was not a disaster, this was a warning. The first shockwave had arrived, and it was a clear message that the main storm was still on its way. The echo of the Sun's fury had reached us, and these magnetic ripples may not stop in the sky, they could even shake the ground beneath our feet. This is one of the most surprising and debated connections in space weather science, the idea that a storm in space could affect the solid Earth itself. For a long time it was thought that the ground beneath us was completely isolated from the events happening in the sky, but new research is starting to challenge that idea. The link is not direct, but it is compelling. It is a hypothesis that connects space weather to seismic stress, the stress on the tectonic plates that make up the Earth's crust. It's a new frontier of science, exploring how our planet responds as a whole to the forces from space. The theory works like this. When a high-speed solar wind stream from the Sun hits the Earth, it compresses our magnetic field. It is like a strong wind pushing against a balloon. This puts pressure on our planet's magnetosphere. But what happens after the storm passes? The solar wind can suddenly drop in density. The pressure is released. The magnetic field, which was squeezed, can now expand back outwards. This expansion can be very rapid. It is this sudden drop in pressure that is the key. The hypothesis is that this low solar wind density, this sudden release of pressure, may trigger earthquakes. The idea is that the Earth's crust is already under a lot of stress. Tectonic plates are pushing against each other, building up pressure along fault lines. Most of the time, this pressure is held in check by friction, but sometimes all it takes is a tiny little push to release that built-up stress. When the space pressure from the solar wind drops, the Earth's crust can slightly flex. It is like a vacuum expanding. The change is incredibly subtle. It is a tiny, tiny change in pressure on a planetary scale. But in a place where a fault line is already on the brink of slipping, sometimes a tiny push is all it takes. It could be the straw that breaks the camel's back. It is important to be clear that this is not a proven fact. It is a correlation that some scientists have noticed. They have looked back at the history of large earthquakes and the history of solar activity, and they have seen some intriguing patterns. They have seen links with high-speed solar streams from the Sun. But it is not yet a predictive science. We cannot say that a solar storm will cause an earthquake, but we can say that there seems to be a connection. And right now, that connection is more relevant than ever. The powerful solar activity we are seeing could lead to exactly these kinds of conditions, a massive storm, followed by a sudden drop in pressure. And as it happens, a 7+ magnitude quake alert remains active for several high-risk seismic zones around the world. These alerts are based on ground-based measurements and historical patterns. They have nothing to do with space weather. But the timing is another one of those strange coincidences that are piling up in this story. On a map of the world, we can see the planet's seismic zones glowing faintly, the San Andreas Fault in California, the Ring of Fire around the Pacific Ocean. These are the places where the Earth's crust is under the most stress. And as the storm from space washes over our planet, these areas might be feeling an extra invisible nudge. The ripples from the Sun might not just be in our magnetic field. They could be deep in the rock beneath our feet. While Earth trembled, scientists turned their attention back to the source, to the object that started it all. The immediate effects on our planet were a cause for concern. The geomagnetic storms, the potential for earthquakes, these were urgent issues. But to understand the big picture, to understand the why behind this whole series of events, we have to look back at the visitor. We have to go back to 3i Atlas. What is this object made of? What are its secrets? What kind of chemistry did it bring from its distant home? As the object began to move away from the Sun, getting fainter and harder to see, scientists were in a race against time to analyze all the data they had collected. They were trying to build a portrait of this alien traveler. The first clues came from its light. By looking at the spectrum of the light reflecting off the object, scientists can figure out what it is made of. It is like a chemical fingerprint. Each element and molecule absorbs and reflects light in its own unique way. And the fingerprint of 3i Atlas was very strange. It showed the presence of things we expected, like carbon dioxide or CO2. But it also showed a surprisingly high amount of nickel, and at the same time it seemed to be low in iron. This nickel-rich, low-iron composition is not typical for objects in our solar system. It hints that it was formed in a different kind of environment, perhaps around a different kind of star. The data also showed traces of water, but not in the huge amounts we would expect from a typical comet that brightened so much. This strange makeup helped to explain some of its weird behaviour. The lack of a comet-like tail, for example. If the brightening was not caused by a lot of water ice turning to gas, then it would not produce a big watery tail. The strange spectral readings were a puzzle. It was giving off a mix of signals that did not quite fit any category we have. It behaves like neither an asteroid nor a comet. Asteroids are mostly rock and metal. Comets are mostly ice and dust. 3i Atlas seemed to be something in between, or perhaps something entirely new. A new class of cosmic object that we have never seen before. It was a chemical messenger from an unknown corner of the galaxy. And it was telling us that the universe is even more diverse and more surprising than we ever imagined. And still, In the face of this incredible opportunity, a frustrating fact remains. NASA did not send a probe. This was a once-in-a-history chance to study an interstellar object up close. We knew it was coming. We tracked its path for months. We had the technology to send a small, fast spacecraft to fly by it, to take pictures, to sample the gas and dust around it. We could have answered so many of the questions it raised. Is it really rich in nickel? What other strange materials does it contain? What does its surface actually look like? But the decision was not made. The window of opportunity was missed. Probes like this take years to plan and build. We have to be ready. We have to have missions on standby, ready to launch when a target like this appears. This time, we were not ready. And so, we were left to study it from millions of miles away through the blurry lens of our telescopes. We got a glimpse, but we missed the chance to truly know it. It was a historic missed opportunity, and one that scientists will be talking about for a long time. And now, as it fades into the black, its data is fading too. The visitor is on its way out. Its journey through the inner solar system is over. It has swung around the sun, and now it is heading back out into the cold and the dark. It is moving away from us, getting dimmer with each passing day. Soon it will be too faint for even our most powerful telescopes to see. It will become just another ghost in the graveyard of space. Our chance to study it is coming to an end. And with its departure, a new kind of mystery is beginning. A mystery not of science, but of silence. The last official observation from NASA was on October 29th. That was the day of Perihelion, its closest approach to the Sun. That was the day it flared up so brightly. That was the day our solar probes watched it fly through a solar storm. We got a flood of incredible data on that day, and then, after that, the official channels went quiet. There were no new press releases, no new images shared with the public. The daily updates on its position and brightness seemed to slow down. For an object that had just become one of the most interesting things in the sky, this silence was strange. The last visible images available to the public came from the stacked C3 coronagraph data on October 26th, a few days before the main event. These were the images that showed its path through the Sun's outer atmosphere. But the images from the peak of the event, the moment of its brightest flare, have not been widely released. The narrator's tone here becomes more investigative. This is not to suggest a conspiracy. But it does raise questions. NASA confirmed its path remained stable, but they released no new detailed images of the object itself after its flare-up. Why? There could be many simple reasons. Maybe the data is still being processed. Scientific data from space probes is very complex, and it takes a long time to clean it up and make it ready for the public. Maybe they are still studying it, trying to understand what they are seeing before they announce it to the world. Science is slow and careful. That is a good thing. Or maybe they saw something so strange, so unexpected, that they want to be absolutely sure of what it is before they say anything. We do have some confirmation about its path. A scientific paper by researchers named Kui-Chen Zong and Carl Batams was published, confirming the trajectory stability. They used all the available data to show that the object's orbit did not change. It followed the laws of gravity perfectly, even during the storm. This is an important piece of the puzzle. It tells us that the forces acting on it were not strong enough to push it off course. But it does not tell us what happened to the object itself. What caused the flare? What does it look like now? Has it broken apart? Is it still glowing? The data is vanishing as the object itself vanishes into the distance, and we are left with a story that feels unfinished, with the most exciting chapter still waiting to be read. But while 3i Atlas moves away, Earth is about to face another cosmic amplifier, the Supermoon. The story of the visitor may be coming to an end, but the story of the solar storm is not. And just as one cosmic player leaves the stage, another one is about to enter, and this new player is much closer to home. It is our own moon. On November 5th and 6th we will have a full supermoon. A supermoon is a full moon that happens when the moon is at its closest point to Earth in its orbit. The moon's orbit is not a perfect circle. It is an ellipse, so sometimes it is closer to us, and sometimes it is farther away. When a full moon happens at the closest point, it looks a little bit bigger and a little bit brighter in our sky. That is a supermoon. This upcoming supermoon will be particularly close. It will be only about 356,000 kilometers away from us. This is very close in cosmic terms, and its position in space at this exact time is what makes it so important to our story. The visuals would show the Moon's orbit as it passes around the Earth, and you would see it intersecting with a long invisible tail stretching out from the Earth, away from the Sun. This is Earth's magnetotail. It is the part of our magnetic shield that is stretched out by the solar wind, like a windsock in the breeze. It is a region of our magnetic field that is full of trapped plasma and complex electrical currents. It is a very active and sensitive part of our planet's space environment, and right at the peak of the incoming solar storm, our Moon is going to fly directly through it. The Moon will drift through Earth's magnetosphere. This is something that happens every month, but this time it is happening at the worst possible moment. When the Moon, a large rocky body, passes through the magnetotail, it creates a disturbance. It is like putting your hand in a calm stream of water. It creates ripples and eddies. In the magnetotail, it can cause the magnetic field lines to reconnect in an explosive way, a process called a substorm. This can send a burst of energy back toward the Earth, so the Moon itself can amplify the effects of a solar storm. It can take a storm that is already happening and make it even stronger. It is another cosmic amplifier, a force that can magnify the turbulence right when the solar storms from the Sun are predicted to intensify. The timing is once again incredibly precise. The monster sunspots are rotating to face Earth. They are expected to be in the perfect position to launch a storm directly at us around the 4th or 5th of November. And the supermoon alignment, the moment the Moon enters the magnetotail to amplify any incoming storm, is on the 5th and 6th. The two events are happening at the exact same time. The predictions for this period are already dramatic. We can expect auroras across continents far beyond their usual Arctic homes. We can expect radio disruptions, affecting communications for airplanes and ships, and we could see possible power grid fluctuations as the magnetic storm induces currents in our long power lines. The supermoon is not the cause of the storm, but it is arriving at the perfect time to make it worse. It is another piece of the puzzle, another cosmic force stacking up against us. If the Sun decides to fire another major CME during this alignment, Earth could face the strongest geomagnetic storm in decades. This is the moment where all the different parts of our story come together. The angry sunspots now facing Earth, the sensitive time window created by the supermoon alignment, and the vulnerability of our modern world. If all these things line up perfectly, the result could be a storm unlike anything we have experienced in our lifetimes. We are talking about a G5 level storm, the highest level on the scale, an extreme geomagnetic storm. This is not science fiction. This is a real, physical possibility that space weather forecasters are taking very seriously. So what would a G5 level storm actually mean for us? The implications are serious. First, our power grid could collapse. A powerful geomagnetic storm can create electrical currents in the ground. These currents can flow into our power grids through grounding wires. They can overload and destroy the giant transformers that are the heart of our electrical system. These transformers are huge, expensive, and take months or even years to build and replace. If enough of them are destroyed at once, it could lead to blackouts that last for weeks, months, or even longer. This is not just a light switch going off. This is the entire system failing on a massive scale. Second, our satellites would be in grave danger. A G5 storm floods space with so much radiation and so many charged particles that it can burn out the sensitive electronics on our satellites. We could lose hundreds of them in a matter of hours. This would mean the loss of communications, weather forecasting, and of course, the GPS system that so much of our economy depends on. Banking, shipping, farming, emergency services, all of it is linked to GPS timing signals. We would be thrown back into a world without this crucial technology, almost overnight. We can compare this potential event to the famous storm of 1859, the Carrington event. That was the most powerful geomagnetic storm ever recorded. It was so strong that the northern lights were seen in Cuba. Telegraph systems, the high technology of the day, threw sparks, caught fire, and gave their operators electric shocks. If a storm of that size hit us today, the damage would be 1,000 times worse. We have built a civilization that is completely dependent on electricity and technology. Electricity, GPS, the internet, banking, all of it is linked to the sun. We live inside a fragile electronic bubble, and a G5 storm could pop that bubble. The narrator's tone is now at its most serious. We are more exposed than ever before. We have more to lose. And the sun, the star that gives us life, does not care about our satellites or our power grids. It is a force of nature. And when it decides to unleash its power, all we can do is watch and hope we are prepared for the consequences. The edge of the storm is here, and we are standing right in its path. But maybe this is less about destruction and more about awakening. It is easy to look at a story like this and see only the danger, the threat of a powerful solar storm, the potential for chaos and disruption. It is a frightening prospect. It makes us feel small and helpless in the face of these huge cosmic forces. But perhaps there is another way to look at it. Perhaps these events are not just a threat. Perhaps they are a message, a reminder, an awakening. The universe is a violent and chaotic place, but it is also a place of incredible beauty and wonder. And sometimes it takes a dramatic event like this to make us look up and pay attention, to remember that we are part of something much, much bigger than our everyday lives. 3i Atlas is leaving. Its short, dramatic visit to our solar system is coming to an end. Its orbit will carry it past Jupiter and then out toward the void. It will fall back into the cold and the dark of interstellar space, maybe never to return in 1,000,000 years. It was a fleeting visitor, a guest that stayed for only a short time. But what it left behind is more than just a trail of scientific data. It left behind a reminder that our solar system is not an isolated island. We are connected to the wider galaxy. Things can come from other stars and visit us, and when they do, they can interact with our own system in ways that are profound and unexpected. They remind us that the universe is a busy, interconnected place. The events of the past few weeks have also reminded us that we are part of a living, breathing solar system. We often think of space as static and unchanging. We see the sun in the sky every day and it looks the same. We see the planets as steady points of light, but this is an illusion. The sun is not static. It is a dynamic, ever-changing star with moods and storms and cycles. Space is not empty. It is filled with invisible forces, with winds and currents and magnetic fields. Everything interacts. Everything resonates. The visitor from another star affected our sun. The sun's storm is now affecting our Earth. Our moon will soon affect that storm. It is all one single, complex system, and we are living right in the middle of it. The visuals would now be slow and beautiful. We see the fading image of the comet, a tiny speck of light disappearing into the black. We see the majestic, glowing sun, with graceful loops of plasma rising from its surface. Quiet, thoughtful music begins to build in the background. Perhaps the purpose of a story like this is not to scare us, but to inspire a sense of awe at the power of the universe, awe at the intricate connections that link everything together, and a sense of humility, a recognition that we are not the masters of our environment. We are passengers on a small, fragile planet, riding through a cosmic storm. Maybe 3i Atlas was not here to destroy. Maybe it was not a trigger for disaster. Maybe its true purpose was to remind us that the universe still speaks, and sometimes it speaks through fire. This story is still unfolding. The sun is still active. The data keeps changing. So stay tuned, subscribe, keep your eyes on the sky, and remember, the next flare might already be on its way. This is Deep, signing off until the next flare.